Thank you for joining us today on this webinar. I'm Jen and I work with the 2GM Groovy Girls Micronaut team here at Object Computing. And we're excited to have our special guest presenter, and I'm honored to introduce the legendary Dr. Venkat Subramaniam. He's also a member of the Micronaut Foundation Technology Advisory Board, which is a wonderful addition to the foundation teams. Today, Venkat will be discussing how to create and test Micronaut applications with a focus on Kotlin. As a reminder, we do have all of the participants muted during the presentation, but please do load up your questions into the Q&A section as you have them. And we'll be doing a live Q&A session at the end and answer as many questions that you all have as time allows. And as a reminder, we are also recording this session and we'll plan to make it available to view on demand afterwards. I believe that is all for me. So I will go ahead and turn it over to Venkat to get us going on some informative Micronaut tutorials.
Thank you so much, Jen, and want to thank everyone who has joined. I really appreciate you taking your time. Also, as a quick note, I'm delighted to say that we have Jeff Brown, who is a very key member of the Micronaut team with us today. He will be answering questions along the way. So if you're posting any questions on the Q&A, Jeff will be answering them along the way as well. It's definitely a great pleasure. And also I request Jeff to jump in using the audio anytime he feels free, fit to maybe clarify or expand on some details. He is most welcome. It's not an interruption at all. It's a great pleasure to have him with us also. So I want to talk about Micronaut and microservices. I'm going to use Kotlin as a vehicle, an example tool to really write the code here. But what I'm going to talk about is going to be useful in any of the languages that are supported. You could use Java, you could use obviously Kotlin, you could also use Groovy to build your applications. And very soon you should be able to use Scala as well as a first-class citizen to build applications. So you could be using one of different languages to build your applications using Micronaut. Now, I come from years of experience with different programming languages, and I always look for things that make the life of programmers easier, more productive, and runtime performance is definitely very important, but I also look for programmer productivity along the way. And that's one of the things that drew me into Micronaut, is to look at the ease with which we can build microservices. So for the next several minutes, I'll talk a little bit about Micronaut and microservices, and then I'll jump in and look at some code examples. And we got quite a few things to talk about in the next about hour and a half we have with us, give or take approximately. So one of the key things in the world we live in is a lot of us are moving towards and exploiting microservices. Now, one of the really nice things about microservices is that microservices are expected to be relatively small, but microservices are also expected to be autonomous. You want to be able to build microservices based on one specific area of domain. So one of the key things in microservices is to bring in the domain context into the picture. So you want to really not slice the applications based on technology boundaries. You want to really slice the application based on the domain boundaries. And oftentimes people say that when building microservices, you want to also have a relatively smaller team to build these microservices. Yes, that's a really important concern to have. You want to be able to write these microservices fairly quickly for efficiency and maintenance and other things. Another area that's also gaining quite a bit of popularity is the function as service or serverless computing. And again, in these areas, combined with microservices, one of the key things, two things that are really important is developer productivity, like I mentioned earlier, but also really super fast performance, especially startup time. Now, there have been a lot of technologies before Micronaut that have done a fairly good job for the traditional applications, but most of them were created before the time of microservices, before the time of function as services, and before the time of the current demand and the need that we are facing. Now, as architects and developers, you and I both understand one thing really well. Every application, every product becomes legacy sooner than later. And if you take an existing solution and try to make it different and better for a new need, it's incredibly difficult to do and be successful with it. Well, that's exactly what the team realized. And so they decided to start something from the ground up by learning from the past experience, but keeping an eye on the demands of the current and the future time. And that's really what Micronaut is. So Micronaut was created from the ground up to meet the challenges of the current business demands in terms of building microservices and serverless computing and function as services and such. Now, generally speaking, when it comes to microservices and especially function as services, the startup speed and execution speed are really important to really be able to be at a peak of performance. And also when the program is executing, we really want to be able to have a fairly good footprint. Memory footprint is very critical too. And then of course, in terms of applications, microservices especially, and also in reactive applications, we want resilience. That is extremely important. You can never design an application in a way it will never fail. However, you want the failure to be graceful. So you want to be able to treat and plan for failure and be able to deal with it. That is an important characteristics in building these kinds of applications. And of course, what good is any of these if we cannot really respond to change really quickly? Everybody today want to be agile. Well, that's one of the things that drew me to Micronaut is the agility with which we can actually develop applications. So in this case, of course, I'm going to use Java, but I'm using OpenJDK, and I'm going to be using, I think, OpenJDK 14, but you could be using any different versions. If I'm not mistaken, you could be using Java 8 and above for building the application. So you're not forced into a particular version of Java specifically or the implementation of Java either. So there's a lot of flexibility to what you can do. Now, when it comes to Micronaut, of course, Micronaut has been developed for microservices and also for the computing of the demands of the current times, but it's really polyglot as the language is. So you can build applications with Java, as a lot of developers actually do. You can also build applications using Groovy or Kotlin or other languages on the JVM via Java at the moment. Absolutely, you can do that. But of course, if you're using languages like Java or Groovy or Kotlin, you can exploit some of the capabilities of those languages in a way you can program idiomatically using those languages. Now, I mentioned that one of the key strengths is the fast startup time. Now, don't get me wrong, I'm a big fan of a lot of different technologies. I usually try to pick what is better for a given situation or an environment. And I generally try to avoid a blanket statement as to one is better than the other. And it really comes to the context and environment and the team and so on to choose things. But one of the key things I like about Micronaut really is that it focuses on the startup time and lowering the startup time or making it really faster. But one of the ways that it's been achieved is by providing compile time metaprogramming. I'm a huge fan of metaprogramming in general. And in the case of metaprogramming, you are able to really write a lot less code with greater efficiency. And it also is a nice way to honor the drive principle. We're not duplicating our effort thanks to metaprogramming. But a lot of times in my past experience with other tools, namely, for example, Grails is one of the things I've used quite a bit in the past, is the metaprogramming was often achieved using reflection. And over the years, a lot of these technologies have tried to embrace more of a compile time metaprogramming as opposed to runtime reflection to do metaprogramming. Well, Micronaut from the ground up has been designed and implemented with compile time metaprogramming rather than really engaging into using reflection. So that is one of the nice things about Micronaut is it's geared towards the kind of performance from the ground up. Now, of course, one of the really cool things about this is very high throughput. So it's not just a really good startup time, but once it starts up and starts running, it is pretty fast in responding to requests as well. And again, it really is geared towards performance at runtime. And of course, when the program is running, especially in the world we live in where we're going to spin these services very quickly, we don't want to use a lot of memory at runtime. And Micronaut is geared towards reducing the memory footprint. From the programming point of view, one of the things that often excites me is this idea of convention over configuration. One of the nice things about, convention is you don't have to do a lot of work. But on the other hand, though, one of the problems with convention is you got to know what conventions to follow. So there's enough of configuration that's still needed. But I don't think anybody in the world today really wakes up in the morning saying, I'm so happy I'm going to go make changes to one more XML file. Well, that's one of the things I like about Micronaut is the convention is there, but you can configure with almost no effort. And the configuration is in the code as annotations. It's a lot easier to readily make a change to the code. It's hygienic code, and that's what I really like about Micronaut. And of course, you have a lot of sensible defaults, and I always am a fan of sensible defaults because the code simply works the way I expect it to do, and that's one of the things I enjoy with Micronaut as well. And of course, I said dependency injection at compile time metaprogramming instead of runtime metaprogramming. And of course, the convention is also useful to build not just conventional applications, but I'm a huge fan of reactive programming myself. And the fact that you can build reactive applications also gets me excited about Micronaut. I'm going to show that to you towards the end of this. We'll take a little example and make it into a reactive stream and see how easy it is to communicate reactively with it as well. So what are some of the benefits of doing this before we jump onto some code? Well, some of the benefits are speed of development and the speed of execution, smaller footprint when the program is executing, when the microservice is executing. The code is in a declarative nature, so you're not writing a lot of verbose code to get your work done. That's one of the really big benefits you get out of this as well. And like I mentioned, compile time metaprogramming used for compile time dependency injection. And that is one thing that's also an aha moment for me when I was learning Micronaut is that you're able to tell what your dependencies are, but those dependencies are wired together at compile time. And as a result, you're not expending time and effort during runtime to do those wirings and discovery. A lot of this is that is done at compile time for us. And of course, it also supports very nicely cloud native APIs, so you can configure things for running on the cloud. One of the other things that really drew my attention was how you can actually build for how microservices need to be built. And one of them is resilience, I mentioned earlier. But a very important tenet when it comes to building microservices is how do you be resilient? Because failure is definitely a possibility and you want to recover from that. Well, this is where circuit breakers are actually built into the framework, and it's almost effortless to really use circuit breakers. And I'll show you an example of that a little bit later, where we'll make the service fail and we can see that the service actually responds quite easily when that actually happens. And then of course, finally, we again mentioned about compile time metaprogramming. So with all this said, let's now talk about creating a little example and playing with it. I'm going to keep the example itself really small and focused so we can actually look at the effort it takes or the lack thereof and how easily we can work with it. And of course, building on top of it to do more things is a question of just adding more features to your application. So how do I create a web service or rather a microservice, and how can we really respond to it? Well, essentially what I'm going to do is to build a RESTful service, provide a RESTful endpoint, and I'm going to create a client which can be used to go make a request to this particular service we're going to write and get the response and work with it. So essentially in this case, we want to be able to build very quickly and easily. So you can either go to the website and create a project, download the zip files. which is perfectly fine if you want to do it. But I'm more of a command line person myself. So what I'm going to do here is to use the tool, the MN tool here to build that particular application. So I'm going to say a create app. The CLI tool is MN for Micronaut, and I'm going to create application. And if I don't specify a language, it defaults to Java. So I'm going to say, let's go ahead and use Kotlin in this particular case. And then of course, I'm going to specify the application I want to create. But when I create the classes in my application, I would really like to create these classes within a package. So I prefix the application name with the package name right here. In this case, I said com agile developer stock prices dot stock prices, the package name followed by the name of the class I want to use. So essentially in this particular case, we are able to simply drive the specification of the package name along with the project name in here, as you can see. So that's exactly what I'm going to do in here, is to create this particular package, as we can see. So I'm going to just go ahead and fire it up and execute it right there. And before that, of course, this directory is empty. I don't have anything in here, and I'm just creating this particular application. So right there, as soon as I hit the return, it said the application has been created. So if you notice over here, I've got the stock prices as the application setting. When you create an application, you can either use Maven or you can use Gradle. Well, I personally use Gradle much more than using Maven, but if your choice is to use Maven, absolutely you can ask the CLI to create a Maven build rather than a Gradle build. That's not a problem at all. So in this case, we have created a little application, as you can see. If I look at the application directory, under the test directory, you can see that we have a stock prices test sitting. And likewise, under the source main directory, you can see the application.kt sitting there. So those two have been created for us readily at this point. So all we did was simply be able to create this, simple application. And one of the things I like to normally do is to run the application right away. That way, if there are any issues, I know that there are issues before I put any of my fingers into the code or the project. So I'm just firing up that application right here, as you can see, just to go ahead and fire it up and say, run that. Well, as you can see, it seems to just fire up just fine. Not a whole lot of issues at all. Well, not any issues for that matter. And it's a default using the port 8080. You can configure the port if you want to be a different port. And all you have to do for that is to go into the resources directory, and you can see application.yml, and that file you can just modify and say what port number to use, and it's going to use that port number for firing it up. So you can change the default port of 8080 to something else very easily if you really want to. Now that we created the little application, the next thing I want to create here is a little Pojo to just work with. In this case, of course, the Kotlin. I'm going to create a little stock class that I want to use in this particular application. Well, Kotlin gives you quite a number of interesting bean capabilities. If you really want to create, let's say, for example, if you want to create a singleton, you can do that. But in this particular case, I really don't care for a singleton as much. But even though the little tool that I used is creating that as a singleton, I'm going to just get rid of that and turn this into a data class, because that's what I really want to use in here. So what does this data class really have? I'm going to specify that this data class contains a ticker, which is a string, and it also contains a price, which is an integer. So again, Kotlin uses nice little data classes. Java 15 has records. So if you really want to use Java 15 records, you could do that as well. Whereas here, I'm going to simply be using the data class in Kotlin. If you want to put more functions in here, you certainly can do that as well. Now, in this case, of course, remember, I'm on the service side at this point. So I'm going to go ahead and say that I want to create right now a singleton, essentially as in the object of stock. I could have multiple objects of it. However, I really want to create a companion object within this class using the Kotlin capability. So I say companion, and this is going to be an object, the companion object. I'm going to define within this a function, and the name of the function is going to be fetch price. And ideally, I would be getting the real prices of stock prices, but I can also come close to predicting the stock market simply using a random number generator, as it seems to be these days. So I'm going to create a stock objects with the given ticker, but I'm going to say math.random right there. And this particular random object, I'm going to create math.random and say the price is between 0 and 2000, and I'm going to convert to an integer and return it. So that becomes my little fetch price that's going to just generate a random price and return it to me. And that's a stock objects fetch price function as a static method in the Java lingo, but it's a method in the companion object in this particular case. So we wrote the stock class, and we have created a little application only with stock. But now the next step here is for me to create a controller. Again, you can hand toss all of this yourself if you really want to. Nothing stops you from doing it. But you can also use the CLI nicely to create this without having to put a lot of effort into it. So the CLI just accelerates the development a little bit rather than us having to type all these files. You can use your IDEs of your choice with Micronaut. If you're using things like IntelliJ, absolutely you'll benefit from them as well, but it doesn't force you to depend on anything specific. It's your choice based on what you're really interested in doing. So in this case, I'm going to create a stock fetcher, as you can see right there. And the stock fetcher is the controller that I'm creating. Now, one of the first things you notice in here is you not only got the class for it, but you also had the test being created for it as well. So I'm going to go to the stock fetcher controller test to begin with. I'm a huge fan of writing test and writing code, and Micronaut is built with testability in mind. And honestly, that's one of the things I always look for when I learn something new is how much they promote testability and how much they make it easier to actually do test-driven development. And I was very pleasantly, happy, so to say, when I looked at Micronaut and realized that they are really favoring writing tests from the ground up. So of course, I'm going to go ahead and bring up the main in here and go to the class stock fetcher controller. But what I'm going to do in here is I'm going to get rid of most of the things in here because I really want to drive through test cases after all. So I'm going to get rid of that and do a test-driven development on this one. Even though we're not going to write a lot of code, I really want to enjoy the journey of ability to write code and write tests. That becomes really important. So in that regard, what am I going to do? Let's jump in and look at using a test. Now, from the testability point of view, one of the gnarly issues oftentimes is when you develop a service, there are a lot of moving parts in it. And the more moving parts you have in it, the harder it is to test those things. Well, one of the things that Micronaut has done really well is it spins up an embedded server for you very quickly. And by having that embedded server, you are able to very nicely test the code very quickly without having to spin up an external server. And that gives you speed when it comes to developing applications using tests, because the fewer moving parts it is, the faster is the development without compromising getting the feedback loop, which is very important for us as developers. So what I'm going to do in here is I'm going to deviate a little bit from the stuff that is generated here. So I'm going to go ahead and first of all, let's get rid of this part because I got rid of the code for that as well. And what am I going to do in here? Well, the first thing is I'm going to go ahead and use an annotation to create a little client as an interface. Now, remember compile time meta programming. So Micronaut has the intelligence to do all the plumbing for us based on the convention and the specification we write at this point. So what I'm going to do is to define a little client. You can keep this in a separate file if you really want to. And you might, if you're writing multiple test files to share that particular client, you can definitely do that. But I'm just being a little lazy here to keep this right here in the same file. I'm going to call this as stock price client, if you will. So I'm going to just simply call it as a stock price client. And once I create this as a little client, I'm going to provide a get on this one as a method of request I'm going to make on this RESTful endpoint. And I'm going to call a price as an end URL. I'm going to say it's going to take some tickers as a parameter or a value that I'm going to pass in this particular URL. And of course, the function I'm going to write here is get prices. You can call that function anything you want to call it, as long as it's a legitimate name that you can provide for the function. And in this case, tickers and string, and the return value is a list of stock that I'm going to return from this particular call. Now, obviously, for this to work, we need to bring in the client in here into annotation. And I'm also going to inject this dependency into my test very quickly. And as a result, I'm going to just go ahead and bring in some annotations, or rather imports right here. So I brought in the HTTP client annotation and HTTP annotation dot star, but I'm going to use inject in just a minute. So I brought that in here as well. So the next step here is to do dependency injection. Now, one of the nice things about this is by the time I'm done writing the test, I not only have tested my controller that I'm going to write, but it also helps me to see how a client is going to look like when I'm about ready to write a client as well. So in the code right here, I'm going to go ahead and create a inject. And what am I going to inject? Well, I'm going to inject a stock price, a price client, which is going to be an object of stock price client that I have defined up there as an interface. Now, in Kotlin, of course, when you create a variable, you are expected to initialize it right away. And if you don't want to initialize it right away, well, it's going to complain. The compiler is going to complain because the Kotlin compiler is built to perform a lot of error checking at compile time. So to get around that, I'm going to say let init on this one to say, I'm going to just, come back and initialize this a little bit later. Now, the dependency injection will initialize it for me, so I don't have to really do anything with it. So I can just stretch my hand and have access to that particular object that is wired to talk to my service. And now, of course, I want to write a test to talk to that particular service. So what am I going to do for that? Well, in this case, I'm going to create a function for testing the get prices function that we have not written yet, obviously. But what am I going to do in here? I'm going to say stocks is equal to, and I'm going to go to my stock price client that I wrote right there. I'm going to ask for get prices from this one. I'm going to provide a bunch of ticker symbols, if you will. Just these are purely hypothetical, and I'm going to just provide a few of these, as comma separated. Again, it's your design how you want to pass those to the request URL. You can do that. Now I'm going to simply assert equals, and I want 3 responses on the stocks that I get back. So I'm going to simply assert and say, make sure that there are 3 responses in the response. And I'm also going to assert at this point, the first one that I got back was Google. So stocks square bracket 0.ticker, and that tells me that the first one is Google. And then of course, assert equals, and I'm going to say, well, in this case, let's say assert true. And since I'm going to use an assert true, I better go back up here and change that to a star. And I'm going to simply say assert true. And this is going to be simply returning stocks, let's say 0, dot price better be greater than 0. That's the first test I've written. Obviously, the test will fail right now because I don't have the code to really support it yet. But my goal is to really be able to support this particular function and make it pass when we have this implemented. So what am I going to do next? I'm going to go to the controller at this point. And in the controller, first of all, I want to turn this into a controller. That is the first annotation that we are going to use over here. So I'm going to say that this is a controller. And in the controller, I'm going to just say that's the URL I want to process. And in this case, it's a get is the method I'm going to take. And then, of course, I'm going to simply say the URL for that particular method is a price, not just going back over here. That's what I defined over here. In fact, I can just take this one and just bring it over here. And that's basically the get prices that I want to implement. But what am I going to do within this particular function? Well, I want to say tickers dot, and in this case, I want to split them based on the comma separation. And once I do, I want to perform a map operation and go to the stock and get the fetch price and return the price value from it. So that becomes a very simple implementation, if you will, of simply returning that particular fictitious stock price that we are creating and returning the response to it. So that is basically all the code we had to write so far for this. Obviously, we need to make sure we don't have any compilation errors. I mean, I could have fat fingered things into it or forgotten to bring some things, but we can figure that out. So I'm going to simply go ahead and say Gradle W and run that test right now and see if the test were to execute or if I get any errors for the code I actually wrote so far. So in this case, of course, I'm just running the Gradle W and running the test, and it's going to fire up the test that I wrote, execute the test, and if the test passes, everything is great. Otherwise, we'll deal with the errors and move forward. Now, in this particular example, you can see it says the test passed, but I'm usually quite nervous when I don't get any failures. Just call me silly. That's the way my mind is wired. I want to know that I have written things that actually work. So I'm going to change this to a 4. And typically I would have run this even before this, before I came back to run the code or write the code. But I want to make sure it's failing before it passes as well. And that gives me a better confidence that I'm actually working with code that is doing the right stuff. So I'm executing the test right there. We can see the failure. That makes me a little bit better that I'm actually not dreaming and it's actually code that's working. And go ahead and run that code and see the test is passing. Now that the code is passing the test, I want to quickly try this out before we go any further. So what am I going to do? I'm going to just fire up another window right here. And let's leave that here. We'll come back to this in just about a minute. But let's go over here and let's go ahead and say the Gradle W and let's run the application. And as soon as the application starts up, let's go ahead and say open. And I'm going to simply copy and paste this URL that we have right in here into this window. And I'm going to ask it to fire up the URL, which is a price as we wrote it, just to be sure I called it the right one. So go back and take a look at it. What's the URL I created for this one? And the URL was a price, as you can see right there. I'm going to specify the tickers I'm interested in. So let's say Goog and AMZN. Let's say just 2 values and fire it up into the browser and see what it tells us in the browser. So the browser fires up there and you can see the fictitious price for those popping up. Surprisingly, that's probably not far from the real price for Google at least. So you can see the prices popping up right there. And that's basically how the code actually performed. So let's quickly take a look at what we did so far before we write the client-side code to come back and interact with this one. So the effort we put in so far, I know I did a lot of talking than coding, but what did I do here? I created a test as in the principle of test first development. And in that test, I first of all created a little client interface to let Micronaut do the auto wiring of the things for me. And I defined this client to have a get prices as a function, which works off of that endpoint. And it takes tickers, which is a string, and returns a list of stock. Then I dependency injected that's a compile time dependency injection into this test class, and then made use of that readily to make the call to that service. My effort is so less to simply say, hey, I want to call that service and get the response for myself. Well, that is the example of a code I wrote to fire up the service and call into it. Now, how do I write the client to talk to this as well? So in order to talk to the client, I'm going to simply create a client project. As you can see, very easy to go through those steps. I'm going to let this one running over here, but I'm going to go over to the previous directory where we have the stock prices. I'm going to simply say that I want to create a client application, and the application is, I'll call it as a stock client here as the name of the application I'm creating. Now, notice I created this not as an app, but as a CLI app. It's entirely up to you. It's not unusual for one service to be a client of another service. In that case, you would have simply said create app rather than create CLI app. But in this example, I just want to create a CLI application because that is quite sufficient for my particular demo in this particular case. So what am I going to do? I'm going to edit right now the file, which is the stock client command.kt. Now, in this particular file, I want to minimize my effort again to be able to talk to this particular service, but I can use a lot of stuff I already did from the other project. However, one of the tenets of microservices, and we have to really talk about this with a bit of a sensitivity, is, one of the things I care about a lot when it comes to writing code is the dry principle. And I've spent a lot of time thinking about the dry principle. But when it comes to microservices, dry principle takes a little bit of a less importance compared to isolation and autonomy of services. And that is something we need to be really careful about when it comes to microservices. The goal is not to optimize and share the code. The goal is really to be able to keep the microservices in isolation. And also keep in mind, the needs of a service are different from the needs of a client. Just to emphasize this point, I want to, first of all, go ahead and create a class on the client side. So I'm going to edit source main Kotlin. And notice in this case, I'm going to create a stock.kt. Now you may say, wait a minute, you created a stock in the server side, didn't you? Oh, totally, I did. However, remember the server-side code was in a different package than in the client, stock client package. That's the first thing. The second thing about the client is that the client does not require the fetch price function. That's a server-side function, not a client-side function. So what am I going to do? Well, clearly in this case, if I edit the source main Kotlin, the stock.kt, I don't care about this part after all. I only care about that part, which is exactly what I'm going to bring in here as the only thing I need. And I'm going to just leave that part alone. So data class stock has a ticker and a price. That's it on the client side. Yes, that's a duplication of code, but I'm not maintaining a common code between those two because I don't need to. If there's a reason for you to share it, you can use a sidecar pattern and bring that in, but that's kind of unnecessary in a lot of different cases. So we just brought that in here as a stock. As you can see, that's all we did. Now going a little further in here, if I were to edit the source main, again, going back to this, the stock client command.kt, well, that's the package is called the stock client. I didn't give the full package name after all. So that is quite enough to use the stock client right there. But then what I'm going to do is to use that particular stock in this particular scenario. So how do I use the stock? Well, first of all, you need to be able to talk to the service. But remember the test we wrote is quite sufficient to get us started on this end. So if I go back and look at the test class, I can readily take this part that I wrote right here in the test and bring it right here into the client. Because after all, the test already showed me how a client would interact with the service. That's one of the things I like about test-driven development is it quickly puts me in the shoes of a user of a code even before I write that code. So after all, if that's a spirit of it, I should be able to leverage that very quickly. So I just brought that in here, as you can see, and we said client and of course, stock price client, and then we simply brought that in here. So once we did that in here, now I want to make use of that. I can get rid of a few things I'm not going to use in this particular case. So I'm going to get rid of all of those things because I don't need that for this particular little demo. And what am I going to do here? Well, first of all, I need to inject the dependency after all, again, much like what we did in the test itself. So I can simply do a late init on that one and bring that in here like I did in the test. It's almost the same as what I'm going to do in the test after all, in this case, isn't it? Well, now that I brought that in, what's the next step? Well, the next step here, of course, is to be able to call into that service and make use of it. And that should be relatively easy to do. So in the run function, all I'm going to do simply is to say that value tickers is equal to, let's create a bunch of the tickers. Let's say Google AMZN, and maybe ORCL, just come up with 3 values in here. Then I'm going to say print line, and I'm going to simply add over here getting stock prices for the tickers, and we'll just print it. But how do I get the prices for these tickers? So I'm going to say stock price client that we wrote as an interface, and I'm going to simply say get prices on the tickers we wrote, and then simply go ahead and ask for each one of them and simply print it. And that's all I'm going to do right here is to print line it. So hopefully that is going to just talk to the service that's running. But wait a minute, where is the URL that I'm going to talk to? Well, the URL obviously is not a slash, because in the case of a test, it was an embedded service. So that's going to change right here. And I could try to hard code the URL in here, but we all know hard coding is a really terrible thing to do. We don't want to do it. So I'm going to lose a level of indirection. So I'm going to say stock, in this case, stock prices is the little ID that I provide for this one. Let's see how I'm going to wire this together at this point. Well, before we go that route, one of the first things to make sure we do is to bring in the HTTP client into this particular client, because we just created a client project. So I'm going to go to the build.kts, and in the build.kts, I'm going to bring in some dependencies I will need. Actually, specifically, I need one of them to be brought in here, which is going to be in the test implementation. You can see that we have the HTTP client, but I'm going to also bring that in as an implementation because I need that during runtime as well. So I just simply brought that in as an implementation. Now, the next thing I'm going to do in here is to specify where to go look for the service, right? I need to specify the URL for it. So let's go to the source main resources application.yml. And in this file, we're going to configure the location where we want to get the service from. Obviously, you don't want to hard code that into the code. I mean, you could if you want to, but you don't want to really hard code it. So all I'm going to do in here is to specify that the HTTP service is going to be stock prices. That's exactly the name that I used right here as stock prices. And then I say the URL for that is wherever that URL is going to be. Later, we will see how we can deviate from that as well. So I specified the URL right there. Assuming I did all that properly and didn't fat finger into it, let's go ahead and do a Gradle W and run the run of the client side and see what it wants to tell us. So I fire up the client at this point and execute it. And you can see in this case, it is going to make a request to the service, which is running on the left console right there. And in this case, let's see if it actually pulls it up. It's taking a little while than it should. But one of the things is in my computer, I can run Zoom, or I can do anything else. And the minute I run Zoom, it seems to suck up all the resources. So even moving a mouse sometimes becomes very slow. So part of the reasons why it's not really great here is the fact that I'm actually running Zoom. Almost it's like an airplane taking off when I start up Zoom. So right there, you can see the response that shows up right there. So we got the prices of the stock for all the 3 of them being printed. Again, very little code, very little effort, and we were able to fire it up and execute it, as you can see. So that's basically an example of creating a client and a service. And of course, one of the key things is we just wrote a little service. That's all we did. But what about the other concerns of a microservice world? How do we deal with all of those things? Well, that's what I'm going to spend time on for the rest of the session, is to talk about some of the ways in which we can handle these kinds of issues and how can we really make this more compliant for building microservices. Well, when it comes to building microservices and function as service, we often want to deploy these on the cloud. Well, one of the nice things about Micronaut is Micronaut works really nicely with a lot of cloud providers. Whether you're deploying on Amazon or Google Cloud or Oracle Cloud or Azure, it doesn't really matter. You can go ahead and execute this on any different number of these cloud infrastructures. There are configuration files you create, application dot, an extension based on the particular cloud service. based on where you're deploying your cloud application, that particular cloud configuration file will be read, and the environment variables you can set in that will get used. So obviously, you're going to use predominantly one possibly, and maybe a couple of cloud services. So depending on the one you want to use, I would refer you to the documentation to focus on that. So you can set it up to run on the cloud, and the deployment options are really available for you to do so as well. Now, I'm going to just create a very simple Hello World application here just to show you how you can actually deploy to it without going into too much detail on the cloud itself, because setting up things on the cloud can take a lot more effort to get your permission set up, account set up, which hopefully you already have, but then you want to make sure the credentials are set up properly. So I'm going to keep it to a fairly minimum here because that involves quite a few moving parts in general. Well, I'm going to use just Google Cloud here, but you could use any cloud for that matter. So in this case, I'm going to simply create a little application, a Hello World application, and I'm going to just populate that in here. So what am I going to do? Let's come back to this application in a few minutes. So let's go over here to a little Hello World application I want to create, and then we will come back and continue with our other application after a few minutes. So all I'm going to do here is to create a little application. But what's the name of the application? I'll call it as Hello World is the application I'm going to create. And I'm using a Jib over here to simply bundle my application into and deploy it. So once I create this application, let me go into the Hello World right here. And I'm going to simply create a very little small service that I want to use in this particular case. So the service is simply going to respond back with only a hello world, not a whole lot else. So all I'm going to do for that purpose is simply use the command line tool that we used earlier to create a little controller. And the controller I'm going to use here is called, hello world. So I'm going to create a hello world controller. Let me go over to the file, the location. So mn create controller, and I'm going to simply say hello world is the name of the controller that I'm going to create. So let's take a look at the main, in this case, I created a Java application. I forgot to put the -l Kotlin, but nevertheless, let's go ahead and say I want to run the hello world controller. And what am I going to do within the controller? Well, I'm going to let the controller run on the slash. The get is going to simply be running off of, let's say, I'm going to simply say greet, and we will say in this case, oh, let's put a location here for a greeting, if you will. It could also be hello universe if you really want it to be whatever you like it to be. So in this case, I'll write the function called greet, and it's going to take a string name as an argument, and I'll simply return hello. Pardon me, the location, right? So I'll just simply return hello plus location. So very little code, as you can see, that I wrote for that purpose. What is the next step I'm going to do in here? Well, I'm going to edit the build.gradle file. Again, if you're using Maven, you could do that very easily with that too. So I'm going to go ahead and say, this is going to be a hello world application that I'm going to create. Oh, but I need to specify the project ID that I'm going to use in here. So I specified a project ID that I'm going to use. And as a result, the next step in here for me is to really bundle this up. So I'm going to say Gradle W and run the Jib option for it, because we created the project with that feature earlier on. And that's going to really go ahead and deploy my application. And the last step is, of ask the Google Cloud to execute this particular application. And obviously, I've spent the time already to set up the project and all those good stuff and perform authentication. So that went fairly smoothly, but you would have to take the time to do that setup if you don't have that already. And the last step here for me is to really set this up on the Google Cloud. So what am I going to do? Well, I'm going to specify right here the project I'm going to use. So G Cloud, and I'm going to run the deployment, and the project ID I want to provide right there. And then I'm going to specify, what is this going to be? Well, that's going to be whatever the example project I just created. But for that, I'm going to go ahead and fire up the build.gradle file again. And I just called it as Jib image right there. So I'll use that one. And so that is going to be the name I provide. And of course, this is going to be the little project ID that I provide for my deployment. So let's go back over here and fire this up. And that's going to install on Google Cloud. And the service name, yes, I'm going to take that one. Where do I want to put it? I'm going to put it under, let's say, the US Central, which is fairly close to where I am. So let's go ahead and take that one. And that's going to go ahead and deploy that. But once the deployment is over, now the application we just created is deployed on the cloud, and we can create a client and talk to it, deploy the client on the cloud and talk to it. Or in this case, I'm going to just go ahead and hit the URL from here using just to open, and the URL is sitting right there. And I'm going to just fire that up right there and say greet. And let's go ahead and say universe, and we will ask the universe, hello universe, to be popping up. Assuming that was deployed properly. Again, you can see a little slow there because I'm hitting across the wire and Zoom is like, hello, remember me? So right there is hello universe that we deployed it. So not a whole lot of effort. As long as you can get everything configured for the cloud you're going to use, that's perfectly fine. But I want to get to the, again, the development aspect of these things, which is one of the key things with microservices, especially, is we often think about scale. Now, from the architecture point of view, you don't look at microservices purely from the performance point of view, you look at it from the scale point of view as well. So if you want to really scale, there are things you need to do, like having multiple instances running. And you want to be able to do load balancing between those different instances as well. So if you want to really do load balancing, how much effort do you want to put in for you to be able to do all of that? Well, if you ask me, generally the answer is as little as I can get away with, because I don't want to spend a lot of time and effort. I want to focus more on my application and value to my clients and less on infrastructure. So what I'm going to do in here is to go to the application we wrote a few minutes ago, the client stock prices, and of course the stock client is sitting here on the right side. So what I would like to do in here, first of all, is to be able to do some load balancing. Well, Micronaut is already built with the code and algorithms for load balancing. By default, they use round robin load balancing, but you can use other configurations as well if you really want to. So as a result, you can simply vary the algorithm if you want to, or simply use the default as a starting point and then change it if that's not sufficient for you. So what can we do? Well, there are some different things you can use for discovery purposes. And one of them is console. Console is already available as part of Micronaut. You can also use Eureka, or if you want to use other solutions, you can find ways to do that as well. So in this case, I already have console running on my system. So I'm going to just have the that being accessed through my Docker image. But before you can use console, if you look at the Micronaut documentation, they will show you example of how you can add a feature to use console. Well, that's great if you're starting out a project new, but we already have a project in place, but I want to use console into an existing project. So what I'm going to do is to go to the build.gradle.kts. In this particular case, I went to the build file for this particular project. This is the project that we already created, which is the stock price. And what I'm going to do in here is to ask it to bring in the dependency on console. So that way I don't have to create a fresh project. I can readily use an existing project and enjoy using a console into it. So what am I going to do? All I need to do is to add a dependency to bring into the discovery. And that's all, right? So just one liner we add and we are off we go. We are ready to make use of it. So what am I going to add in here? So what I'm going to add here is this one line of dependency, and all that is for the discovery. So simply go ahead and put that one line that I have in here. That one line, I'm going to just add into the dependency, if you will, right there. I'm going to just put into the dependency section and just throw that in as implementation. So that says that you are going to use the discovery client dependency for Micronaut. So now that I added that one liner, what am I then going to do? Well, the next step here, this is in the service side rather. Similarly, on the client side, I need to bring in a dependency as well. After all, those two are two separate projects, isn't it? So I'm going to just go ahead and add the dependency onto the client project too. So that's over here. Let's go ahead and say build.gradle and bring in the dependency into the client project. So the next step here is, what do I need to do on the server side? Well, on the server side, remember, we were asking it to run using the default port, which is the port number 8080. Well, that doesn't make any sense anymore, because after all, we want to be able to discover the service. I don't want to hard code the port number because I want to just fire it up on the fly and have that be configured, because that's a lot more effective in what we do. So what am I going to do for that reason? So what I'm going to do for that reason is to go ahead and ask it to use a console as a deployment a tool. So let's go back over here to the source main application, so resources application.yml. And in here, I'm going to simply add a console, and registration is to where the host is going to be run on a local host. And I'm going to run console on 8500. So I just provided that particular location for registration. With this little configuration, you are telling Micronaut that when it wakes up, to go register itself with console, no need for any coding. Notice I didn't change any of my service. I didn't change the controller, didn't change any other code. I only made a change to this configuration in here. That's all I did. So let's close that away. Now, the next step here is to configure the client as well after all. So let's go to the client and say source main resource application.yml. And on the client, what am I going to do? Well, on the client, obviously, I need to tell the client that in this case, it needs to go discover the location of the service based on the URL from the discovery, and not really hard code to the URL when I write the code. Absolutely, because that wouldn't give me load balancing if I were to tie to it directly. So how do we go about saying that? Well, that's pretty easy to do. Going back to the application.yml, I'm going to do the same thing as I did before. So simply to get rid of this HTTP part in here and simply use the console and say, go get that one. But of course, we want to tell it to go get the proper URL, isn't it? So how do we go about saying that to the client? Well, in this case, of course, I've just configured this to go get the location for the discovery. Let's go ahead and fire it up and see how this is going to work. Let me think through and make sure I did everything I need to do. So I configured the service to go use the right application.yml in here as we did. So that basically is in the service. So on the service, I went to the main and then resources and application.yml. And of course, I forgot the port number, didn't I? So let's go ahead and say edit source. And I'm going to say a main. And this is going to be resources application.yml. And here I'm going to simply say that I want to use the service. And the service is going to run on port, which is going to be -1. So make sure the port is random when you start this. So that is my service side that I'm going to use this on, just to be sure. And then, of course, on the client side, I simply asked it to use the console on the client side, which is this part. We configured it. Great. So that's basically the client side code. And I brought in the dependency for the discovery here. And I also brought in the discovery on the server side also. Oh, one more thing. I need to start console, obviously, because I need to use it. So for that, I'm going to use a very nice little script here that's going to help me to get it started very quickly. So I'm going to call this as run console. And all I'm going to do is simply ask it to run the console. So let's go ahead and edit this right here as run console.sh. And all I'm going to do is simply drop that Docker and say port number 8500. And I'm going to fire it up on that particular port. Let's go ahead and fire this up and start it. So I go to the previous directory right here. And obviously, you could be running this in the cloud and rather than running it here locally. And what am I going to do? Simply go ahead and say the run console file is what I'm going to fire up and execute it. So that should fire up the Docker image, as you can see. Now, I'm going to go ahead and start my server. So in this case, I'm going to say the .gradlew run, and that's my first server. that I'm going to start up and ask it to execute. So that should start at some random port, which I don't care about what the port number is. And then, of course, once it starts run on that port number, it should register automatically with console thanks to the configuration we put in the application.yml. Now that has started and it's running. It says registering service to console, as you can see. Let me go ahead and start this on the second one as well. And while that is starting up, let's go ahead and go to the command line for the client. And in the client, I'm going to go to the main. And in the client CLI, I'm going to do something a little different. I'm going to make a request once, but I'm going to make a request a second time, as you can see right there. So I made two requests for the data from twice here, one after the other. Well, in a typical scenario, your client may be interacting with a microservice or multiple microservices, but potentially it's going to make multiple calls with the microservices. Well, when you're making multiple calls with the microservices, if you have a fairly good amount of load balancing, you would want to really switch between services and use them. So now that I made the two requests over here, I'm going to do something a little different, pardon me. I'm going to go ahead and terminate this. Ooh, that failed. Let's come back to that in a minute. So I'm going to terminate this. Anyway, I was going to terminate it. And I'm going to go over to the service main. And one of the things I want to do here is to go to the stock fetcher. And in the stock fetcher, I'm going to make a slight change here for our purpose. So I'm going to say, put the word return, and I'm going to return this data that we have in here from within that particular function. But then before I return the data, what I'm going to do here is simply print out, if you will, just a little note, print line, let's say, processing, and I'm going to just put that processing in there into that service. Okay, that way I can know which service is actually responding to that particular call. So let's go ahead and fire that up right now. And that should start and register with console. And then, of course, I'm going to start the other service. And that failed the last time, but I'm going to try it one more time and see what it does. And if it fails again, we'll take a look at what the problem is. But otherwise, we'll go ahead and fire up the client and give it a try. So going back over here, I'll fire this up. Let me make sure I'm in the right place. Yep. So go ahead and run that and see what it tells us now. And in this case, we have started two service instances of the service, and both have registered into console at this particular point, once that starts up, obviously. And once that gets through that, let's see what's going to happen. Ooh, that did not go well. Let's see what happened here. So let's see, this says unable to start, port already used 80 in use. That's strange, because I do believe that I had mentioned the port number to be -1. So let me verify that I actually updated it properly. So going back over here, I did say, this one here should be a proper configuration. Most likely I messed up in the configuration of that one.
Venkat, you got, I think you've just got the word server instead of service there.
There you go. Thank you. Thanks, Jeff. So server right there instead of service. Got it. Well, it's good to know that I messed up, and that makes it clear that I'm a flawed human being as anybody else could be. So try that again, fire it up. And it did say 80/80 on that one. I should have taken note of it when it did. So that's the first thing that's being firing up over there. And well, when I'm trying it, Jeff, if I was using a real IDE, would it have given me a little feedback that it is, I'm typing incorrectly? Would the DSL come into picture? Not sure if IDE has such a DSL ability. That would be really nice. Maybe a next project. So let's fire this up and execute it right there. So two things executing. Now I go back and fire up the client right now. And when I fire up the client, just keep an eye on both the windows, if you will. And I'm going to print out the processing. And I really wanted to switch between the services on those requests. Ideally speaking, if the load balancing were to kick in, it should really switch between those two services. And let's see if it does. So we fire up, it's going to go to console and say, can you give me the location? And right there, it makes a request to two requests, if you remember. And, and again, of course, it's competing with Zoom here again. But when it finishes, you will be able to see the response come up on both windows, ideally. So we're almost there. So right there, where's the output? So there you go, processing and processing, right? So on the right side, you can see processing. On the left side, you can see processing as well. So that shows you how it was able to switch between those two services. It's a purely a round robin request. That's the default. But if you want to change it, you can change it to other algorithms if you want to. So that load balancing is baked in with almost no effort. And you can vary some of these implementations again, depending on what you really are looking for. Now, a couple of more things I want to quickly finish in the next about 20 minutes or so with us. And that is, what about failure? Well, Murphy's Law, if something can go wrong, it will. Now, when it comes to microservices, one of the key tenets of microservices is that it's got to be resilient. And you don't want to pretend like failure is a rarity. I really wish they didn't call it an exception. I wish they call it normal. And normal simply is things just happen and you got to deal with it after all. So the point really is, what happens when there is a failure? Well, if a service were to fail, it really makes no sense to go back and ping on that service again. That kind of development is called development by hope. Hope is a good thing in life, but not in coding. So you don't want to hope the service is back. You want to be able to hit the service. If it's failed, you want to switch to another service. Now, when do you go back to the older service? Well, only when it recovers. Rather than having to write all this code, the circuit breaker pattern is a very powerful pattern. The nice thing about patterns are that patterns are well-proven solutions that's been implemented over and over and over. The bad part of patterns are design patterns are not code libraries. Design patterns cannot be downloaded and used in the code. That I wish it was, right? So anytime I teach design patterns, I always tell people, patterns are great, but you cannot download patterns and use them. Well, almost. This is exactly what Micronaut has done, is they took the circuit breaker pattern, but they implemented it in the code. So it's not downloadable in the sense of downloadable, but it's already integrated as a pattern. So we can use the circuit breaker in the code, but the circuit breaker is actually a specialization of another pattern they have implemented, which is a retry ability expressed as annotation. I'm not going to show retry here. I'm going to instead show the circuit breaker, but the idea really is built on the retry pattern. So the retry pattern is when a client makes a request to a service, if the service were to fail, then the service will, the failure will be caught automatically by the client-side code, and it will make a retry automatically. And the retry can be configured to how many times it should retry, how frequently should it retry. It also uses a pattern to degrade the retry over time so that it doesn't retry too frequently. Now, built on top of that is really the circuit breaker, where you can tell the circuit breaker, hey, go ahead and retry for me, please, but go ahead and retry at this particular frequency, if you will. And as you retry at that frequency, degrade and delay the retry ever so often as you continue to retry, and giving the time for the service to really recover. So you can do all of that in the application by implementing code very easily for the retry using the circuit breaker pattern. Now the question is, that all sounds great, but what is the effort it's going to take to actually do it? And it turns out the effort is extremely minimum, if you will. So before I go into the solution, I'm going to kill that particular service that's running. So we'll just run one service right now. So that service, I'm going to go to the source code and go to the main, if you will. And in the code, I'm going to go to the stock fetcher controller. And in the stock fetcher controller, what I'm going to do here is I'm going to ask it to say if mat.random. So randomly, I'm going to make it fail is greater than 0.5. Very super algorithm, as you can see. It simply says throw, let's say, runtime exception. And in this case, I'm going to say a message like we normally see in production. Something went wrong, right? So that's basically what it's going to do, is to just, kick the bucket at that random time. So you make a request to the service and randomly it decides to fail. So that is my service, as you can see, and the service is going to just fail flat, and it's going to say, sorry, I couldn't work. Let's go ahead and run the service now. I'm running only one instance of it right now. And randomly, it's going to fail, as you would see. So, but I don't have any retry. I don't have any circuit breaker configured right now. So if I were to simply run this code, what is it going to do? Well, obviously, if the service were to fail, my client is going to fail here because I made a request, it failed. What can I do? That's life in the big city. But that's not very resilient. That's not very polite. I really want this to be more resilient, and I really want to get the response from the service. What can I do for making that happen? Well, the answer to that question is, so right there it processed. So this time it actually went through, as you can see. But on the other hand, if I were to fire it up again, it's a random stuff. I don't know when it's going to fail. But if it doesn't fail this time, I'll move on to talk about failure and see how we can handle it. Well, there you go. Notice it failed on the server, failed on the client. How sad. So what can I do about it? How can I deal with that failure in a more meaningful way? Let's run the server like the way we did. No change to the service at this point. The service is as bad as it was. But on the client side, I'm going to go to the main one more time and go to the client and remember the interface we wrote. So on the interface, I'm going to just bring in this one-liner, as you can see. So I say circuit breaker. And what am I going to do with the circuit breaker? I'm saying the circuit breaker, do a delay of 1 second. I'm a pretty impatient person, as you can see here. So I'm going to give you a 1 second delay. And I want you to make 5 attempts. And there are more configurations you can use. This is just a little sample of what I'm showing you here. There are more parameters you can pass to the annotation. So the circuit breaker simply says, delay at 1 second when there's a failure, give a 1 second to recover, unrealistic, but that's what I've set it to. And then, of course, try 5 times. And if it fails all the 5 times, give up and walk away. If you mix this with load balancing, obviously, when the request fails, it will route to the next one automatically and try it. So that is something you can configure, so it can switch between services. When a failure happens in one, it'll go to another service automatically. If all of them were to fail, well, that's a really bad day at work. You have to just deal with it and come back and respond later on. So this is basically the circuit breaker that we are bringing in here. So in order to have that work, I need to bring in an import right there, which is going to be the retry annotation that we brought in. So now that I brought in the retry annotation, let's go ahead and kick the client up and running and see what it does. Now, obviously, it's going to fail at a random time, so I don't know when it's going to fail. Otherwise, we can increase the chance of failure and try it in a minute. But hopefully, you can see the processing happen, and then it's going to delay and then go back and try again. So right there, the server failed, as you can see. The client did not fail, but the client brought back a response, as you can see. So that's an example of circuit breaker working right there. You see on the left side, the client did processing right there with the failure message being posted. And then the client, on the other hand, simply went back and made a retry and then was able to get the response for the processing. And here we see the response. And the second time I requested, which is the third request, because the first one was failure and a second try. And so that's why you see processing being called 3 times on the server side. And here you see the output twice because we made 2 calls to it. So that gives you an idea about how you can use a circuit breaker. The last thing I want to mention here is one of my personal favorite topics, which is reactive programming. Well, reactive programming is where we are really modeling an application in terms of data flow computing. And this is near and dear to me personally. It really depends on the type of application you are developing. But I'm seeing this more and more among my clients where they are using reactive programming to really take a stream of data and be able to process it. And I was absolutely delighted to notice that Micronaut makes it really easy to do reactive programming. You got a few different options again here, but by default, RxJava API is baked in. I've used RxJava extensively, so my learning curve was really flat coming into Micronaut for that reason. So I'm going to give you a really quick example of how we can create a stream of data. Well, generally speaking, in reactive programming, you have publishers and subscribers. Well, in RxJava, a publisher is created using, obviously, the concept of flowable. And so you can use the flowable and just simply route the flowable onto the caller. On the client side, you simply can attach to the URL and immediately get a flowable, and you can use it as well. The effort is actually extremely minimum. In a way, I would even say it's embarrassingly simple. You just don't want to tell the boss that it's this easy to do and tell them that it's going to take a long time to do and then take the rest of the time off and go do other things that you really have fun with in coding. So what I'm going to show you here is how we can actually use a reactive API and build onto it. So let's give it a try. So what am I going to do? First is I'm going to stop the service right now. Let's go to the service. And in the server side, what I'm going to do is, first of all, take the test that we wrote before. And in the test, I'm going to say, this is the prices controller test. And in the controller, here's the test we wrote earlier. Now, obviously, I'm going to go ahead and bring in here source. Let's go to the Kotlin and go to the stock fetcher controller. And within this, I'm going to get rid of this code we wrote here. And oops, let's get rid of that failure and just get back to the code we had before. Now, what am I going to do? I'm going to write one quick little test. And in the spirit of test-driven development again, what I want to do here is to say that my service now should really have not just a regular API, but I want this to be a reactive API so that when I make a request to this particular service, it can bring a flowable as a response rather than just a list as a response. So what am I going to do for that purpose? So all I'm going to do is the test I'm going to write, first of all, is to go to the client, and I'm going to change this one to say get, and I'll call this as prices, but I'll say RX for being reactive, and then slash, let's say tickers. So this is going to be a reactive endpoint. So fun get prices RX. Tickers, as it was before, is a string, but the return value is a flowable of a stock. So that is the first thing I did in the test, is to say that it's going to be a flowable rather than being a list. Now you can see the effort is so minimum compared to what we are trying to accomplish here. Obviously for this, I'm going to bring in RxJava right there in here. So essentially io.reactivex.flowable, and then the flowable is what we are returning. But what about the test itself? We want to make sure the test is working, the code is working as expected, right? So let's go ahead and say test over here. And this is going to be a function get prices RX. That's what I want to test right there. And what am I going to do? In this case, val stocks is equal to, but this one is the stock price client, but get prices RX. But I'm going to send the same stocks that we wrote earlier for that call. But then I'm going to say blocking first in here. You can use anything that you have access to in the RX library and the flowable. I just chose an easy route here, blocking first. Then what am I going to do? Simply take these two lines right here for the asserts, bring them in here, and this becomes a stock rather than stocks because we got only one stock after all. So stock and dot ticker rather than stocks itself. And then there's going to be stock dot price to get the price of the stock as well, as you can see. So now that we have a ticker and the price brought in, that should really tell us it's working. Obviously, the test will fail because we didn't write the code yet. So I'm going to go to the controller right now. And in the controller, I'm going to go ahead and just copy this over for a minute. And I'm going to change this one to price RX because it's a RX that interface we are writing at this point. So it's a price RX. But then what am I going to do within the code? Well, that's the easy part, right? Flowable already has an ability for us to convert to from an iterable. Well, ideally, you want this to be as fast as possible. But I really want to show you a bit of streaming as well. Imagine that your service is going to take some time to produce data over time. Maybe your service is transmitting the location of a flight And as the flight is moving, it keeps sending the data. So I'm simulating a delay just to simulate a real world situation where the data may be arriving at interval rather than being instantaneous. So what I'm going to do here is the Rx, this is get prices Rx, but change this to, again, flowable. And obviously for that reason, I need to import the Rx flowable. But in order to simulate the delay, I'm also going to bring in the time unit from Java util concurrent. So then what I'm going to do here is to return. Well, I take the flowable, oops, as you can see, my mouse is stuck here. Okay, the iterable is what I want to use over here. Then I take the tickers and I split it like the way I did before, as you can see in here. And once I do that, I'm going to do a delay of 2 seconds, if you will. So time unit dot seconds, as you can see. Then I start putting the output like I did before. So not a whole lot of difference, as you can see. So flowable dot iterable, and from iterable, and taking the collection of tickers, and I introduce an artificial delay, and for 2 seconds delay, I then send the data out. Let's see if the test passes before we go any further. So Gradle W test, and we're about 5 minutes away from wrapping this up. So let's go ahead and run this code and say Gradle W test. And that should really run the test. Hopefully the test passes. Then we can fire it up to run and take a look at the output right after that. So let's go ahead and run the code. And in this case, the test is still executing. And let's see if that passes through. Ooh, the test failed. Let's see what I did wrong. So it's saying HTTP client response exception, default client Java, and it gave me an error at this point. Let's see. This is at a HTTP client response exception. Oh, the problem here is, let's see, this is the test that's running, isn't it? Let me take a look at the code again. So creating a bean class of 3 types, and the line Rx price is where it failed. And that seems to be a failure in the data that it was getting. I'm quite a little surprised at the failure there. So here's the test. So we are sending these 3 values to the object. We're saying blocking first, and that call seems to have failed. Oh, there's a typo in the URL in the service. Thank you. Good catch. Leo, you restored faith in pair programming for me. Thank you so much. Price RX. Let me check if it is correct here. Price RX. You are my hero today. You made my day. You are right. Awesome. So let's go back here, run the code one more time, fire it up. Let's see if that works. And if this test passes, the credit goes to Leo for making this work. So, and I want to bring Leo to pair with me more often if that works. So thank you. You made my day, seriously. So let's go ahead and run that code and see what it does. And there you go. Let's go ahead and fire it up. Gradle W run. But I want to show you really quickly from the browser, like we did before we try to go execute this using a client. So open, and this is running at that port right there. So let's grab that port. And then I'm going to simply fire it up right there and say, this is going to become price RX, AMZN, Goog, and let's say MSFT, and fire it up in the browser. And what does the browser say? The browser is bringing 1 price every 2 seconds, as you can see right there. One more time, refresh it, and you can see that it's pulling it in 1, 2, 3, and it brought it out. So that's an example of how you can stream data with almost no effort. You can turn the URL into a reactive stream if that's what you want to do. How about writing a client for it? That's actually pretty easy. Why? I think we can stop here, because if I can do it here, you're going to do the same thing on the other side for the client, isn't it? So you can call the service, you can do a subscribe on the flowable and simply take the data. You saw it on the test, you saw it in the browser. It's a question of just writing that code on the client side to pull the data on the client and be able to display it. So if you have microservices that are streaming data, well, you can write that very easily with Micronaut. Not only that, you can write the code in a traditional way. And if you decide that streaming is a better option, you can buy into it at a later time with almost no effort. Likewise, you can take your clients and switch them to using reactive streams as well. So the barrier to entry is very minimum to do so. And that is the best part of doing this. So I think we have about 5 minutes or so with us. It's a really good time for us to chat a little bit. I talked quite a bit about the strengths of Micronaut and what you can do with it, but I'm also eager to hear your thoughts and voice. I know Jeff has been active answering a lot of questions. I really thank him for doing so. But I'll also bring Jeff along for the next 5 minutes, and we both can listen to your questions and answer them along the way. So fire up your questions. If you have more questions, we'll be delighted to hear what you have to say.
Yeah, Venkat, that's tremendous information. Thank you very much so far. There have been lots of questions in the Q&A, and most of them have been dealt with, responded to in the Q&A window there. So we're mostly good there, but there are a couple of outstanding questions. One that's not in the window is, why does a man who lives in front of the most beautiful mountains in the United States have a green screen mountain behind him on his webinar? So
because I'm in the basement.
Understood.
I've been stuck in the basement for 8 months now, waiting to get out.
We're all looking forward to that being behind us, of course. Couple of questions are showing up now. A quick one is someone that wants to know what your preference of JDK distribution is. Can you comment on that quickly?
Yes. So my preference for JDK, honestly, is OpenJDK. And the reason I say that is, OpenJDK is current, it's continuously being updated, and it is extremely the most reliable one to use. If your organization wants licensing, then and only then look for different options and use them. But there is absolutely no reason not to use OpenJDK for development purposes. For production, obviously, your organization has to make a right decision based on the support needs and other needs, but there's no reason. And I use OpenJDK, and a lot of my clients actually are quite extensively using OpenJDK as well.
Yep, I agree with all that. Can you comment on productivity and functional differences between using Kotlin and Groovy?
So one of the key differences, in my opinion, is Kotlin has superb support for compile time type checking. And if it really depends on the organization, the team, I am quite comfortable with both of them. I like Groovy for the ability to do runtime meta programming. The plus of that is extremely flexible. The downside is error checking is a lot more harder, and I have to do it. Kotlin strikes a nice balance between those two. In the case of Kotlin, honestly, I cannot write DSLs to the extent I can write in Groovy, so I'm a step behind it. But honestly, it comes very close to what I can do in Groovy. But on the flip side, it gives me compile time verification. So to me, the key strength of Kotlin is twofold. One is fluency, which you also have in Groovy, but the other is fluency combined with the compile time type checking, null checking. Even when you write DSLs, you can get a fairly good check on the DSLs. Those are, to me, really good strengths. Knowing Groovy, it was a lot easier for me to learn Kotlin, so you can go back and forth as well and make your choice based on what your particular preference is, and mix and match them where it makes sense. That's one of the powerful, nice things being on the JVM.
Yeah, taking advantage of the polyglot nature of Micronaut is, that's really appealing to a lot of folks. You don't have to choose between the languages if you've got aspects that it makes sense to write in a language like Kotlin, and some aspects of the same service that maybe you want to take advantage of Groovy's dynamic dispatch or whatever it is. Mixing them is something that makes a lot of sense for a lot of apps. We've really only got about 2 minutes. I'll put one more, and it's kind of a big topic, but I'm interested in your comments quickly on this, Venkat. So you've got a lot of experience with Grails, I know. So one question is, do you think that Micronaut needs a DSL on top of it so it becomes less verbose like Grails? And I'm interested. I too am interested in your view on that. I have my own view on it.
I think DSLs will definitely be useful. There's no doubt about it. But the DSL has to be, I think it's got to still be within the realm of it's got to provide immense value to the users. So it should be really driven by the use cases. And then second, it's got to really be supported by extreme compile time capabilities. So the constraints are a little bit different in Micronaut compared to Grails itself. But I think that it'll definitely benefit from having DSLs in the long run. But it's a question of figuring out how useful it is. I'm not a big fan of introducing a feature for the sake of introducing it. So it's got to be driven by a really, really good use case.
Very good. Venkat, thank you once again for spending the time to help the community understand a lot about Micronaut and Kotlin today. I think we're down to just about 30 seconds here. Jen, have you got anything quickly for the group?
I just wanted to thank you again, Venkat. This was an awesome, awesome presentation, and we look forward to having you again.
Thank you. And thanks everyone for joining. I really appreciate everyone taking the time. And thanks to folks at OCI.
Thank you, Venkat. It's I speak for a whole bunch of people who showed up here today in saying that it's really great to see you, and I'm looking forward to doing that in person soon.